Hello there, my name's Chris and this is Dave, and right behind us is the abandoned silver mining ghost town of Cerro Gordo, California. Cerro Gordo is the subject of the popular YouTube channel Ghost Town Living, and it's owned and operated by a gentleman named Brent Underwood. And Brent's goal for this town is to rejuvenate it and renovate it and bring it up to a level where people can come up here and explore and learn all about the rich history of this very beautiful place. Now, our goal for this visit is to take a look at the internet that they have set up here. They do have internet. However, it's pretty spotty and they don't have coverage everywhere they need coverage. They've got a lot of buildings that have metal siding that we have to figure out how to get the internet in there. So we're going to come up with a design that will work for Cerro Gordo for years to come. And then by the end of this video, we're going to share that design with you guys. All right, Dave, you ready?
I'm ready.
Okay, let's get started. When your goal is to deliver wireless coverage to an abandoned ghost town, where do you even start? We knew that in order to get a complete picture of what we wanted to accomplish, we had to visit Cerro Gordo in person, which is a 12-hour drive from Oregon. And getting up the mountain into town is an adventure of its own. It's 8 miles up a sketchy dirt road. Once we got up the mountain, we met Brent and he took us on a tour of the town and talked about how the internet comes in, where they currently have Wi-Fi, and where they wanted wireless coverage in the future. So let's start by taking a look at what they have today. Cerro Gordo's internet comes from an ISP in Lone Pine, California that travels first to Keeler, California, and then up to a receiving antenna that sits on a mountaintop just to the south of town. Now, due to the snow, we weren't able to get to the ISP's receiving antenna, but Brent told us that it's on solar power, and it has had some issues with losing power when the snow piles up on those panels. That ISP's receiving antenna then beams a point-to-point wireless link over to a second solar setup, which is where the on-site network actually starts. This second receiving station has a 100-watt solar panel and 2 batteries. Inside the enclosure is a Renogy solar charge controller and a MikroTik hex light router. Feeding into the WAN side of the router is a NanoBeam AC Gen 2 that picks up its signal from the ISP's antenna on the other side of the valley. On the LAN side of the router is a Light AP AC120 point-to-multipoint access point, which beams the internet signal down to the town in a 120-degree arc. This is where we see our first issue, in that the LAN for this entire town is coming from this MikroTik hex light router on solar power, right? We want to improve that, but let's not get too far ahead of ourselves. The Light AP AC120 point-to-multipoint antenna on the solar receiving station beams a wireless signal to 2 different locations in Cerro Gordo. First is the Hoist House, which sits well above the town itself, and it's set back behind massive piles of dirt and rock that's been pulled out of the mine over the years. So right here we have the Hoist House network, and I'm not going to cover this too extensively in this video because I did a full separate video on my thoughts on the way that they implemented this design. But basically it all starts with a NanoBeam AC up in the window over here, and it's actually behind the window, which is not ideal. It probably should be on the exterior of the building. And then a cable runs all the way over into this little MikroTik router right here that's really only being used as a switch, and then into this coax connection, which sends a coax cable all the way down 900 feet into the mine where they've got another access point. This setup is still working today, but it's limited in that ideally, Brent wants wireless coverage at every level of the mine, and this only provides coverage at the very bottom without much in the way of expandability. Luckily, Dave has some ideas for improving this mineshaft network, which he's going to cover a bit later in this video. Back down in the town, all of the wireless coverage terminates to the Gordon House. On the exterior, we have a NanoStation AC, which is a station antenna picking up the wireless link from the Light AP AC up on the hill. Now this is a great choice for this location because the NanoStation AC has a secondary Ethernet port that can power up another device. In this case, it's a UAP ACM on the exterior of the building. The UAP ACM serves as the main source of wireless coverage for most of the town, including Brent's house. Right behind me, this is Brent's house, and he said that he gets decent internet inside his house, and notice that it's wood construction. It doesn't have the metal siding that a lot of these other buildings do, which is probably why the signal gets through no problem. Inside the Gordon house is a UAP AC Pro access point, and all of this equipment is powered up by a pair of PoE injectors that are wired together as a mini switch. There's no issue wiring things up this way, but everything was just kind of strewn about on the floor and on the table, and it could use a bit of cleanup to ensure that nothing gets inadvertently unplugged. The only other place in town that has wireless coverage is the famous haunted bunkhouse, which is where Dave and I stayed the night up in Cerro Gordo, though I'm happy to report that I didn't see any ghosts or experience any paranormal activity while I was there, even though I was sleeping in a room with a bunch of creepy dolls. Now, this access point pulls its signal via mesh from the Gordon house, which is way up here on this hill over here. So we've got a point-to-point connection to the Gordon house. The Gordon house has an exterior access point, and that exterior access point is meshing over to this UAP ACLR. This UAP ACLR was hanging upside down by its Ethernet cable strung over a wooden fence and totally exposed to the elements, but actually it was working just fine. And as far as powering up that UAP ACLR, you can see that they went with the exterior PoE injector with electrical tape method. Now that we had a clear picture of their existing network, it was time to get started with a new design. There's a number of ways that we would want to improve this network, as well as make it more robust and reliable during weather events. We want to add in the ability to do dual WAN with something like Starlink. We need to add some video surveillance in the general store and possibly some other locations to help deter theft. And we also want to expand coverage to many new locations around town. Today, they only have wireless coverage at the Hoist House, the Gordon House, and the Bunk House. But we're also going to want to cover the general store, the church, this brand new American hotel that they're building, as well as this small recording studio area to the south of town. We're going to talk about each of these locations individually, but let's start with the general store. We're going to make the general store the main central point for the entire network. If you recall the current setup, the router and firewall for the network is currently on solar power up the hill with the point-to-multipoint antenna. If we pick up that signal at the general store with a NanoBeam AC Gen 2, we can then feed that into WAN 1 of a Dream Machine SE. The Dream Machine SE is an excellent choice for the core of this network since it can do dual WAN, it has Unify Protect capabilities for video surveillance, and it's more than capable of handling all of the network traffic for the entire town. We'll put the UDM-SE into a 4U rack enclosure along with a 1U UPS so that the whole thing can be physically secured in a locking cabinet, and we'll have good, clean UPS power to keep it running smoothly because the power up on the mountain can actually fluctuate quite a bit. For those eagle-eyed backseat driving network engineers watching this video, you may have already spotted one issue with the setup that I just described. The wireless link coming in from the solar setup on top of the hill is already going through that MikroTik firewall. So by plugging it into the WAN side of the UDM-SE, we're going to be creating a double NAT situation. This isn't ideal, but since they're not really doing anything other than regular web surfing, it shouldn't be too much of a problem. Now, I typically try to avoid double NAT at all costs, but to me, the trade-off of moving the core of the network to a secure location that's not on solar power outweighs the downsides of double NAT. Another advantage to having the UDM-SE in this location is that Brent can add in a secondary internet connection such as Starlink. Now, you wouldn't want to put Starlink up on the hill with the solar setup because it just draws way too much power for the size of solar panel and batteries that they've got installed. They'll now be able to use Starlink as a backup source of internet with the wireless ISP connection as the primary, or vice versa, right? Starlink could be the primary and actually maybe a more solid connection than the multiple hops and dual solar stations of the wireless ISP's connection. At the very least, having Starlink as a secondary means that the internet connection won't be nearly as susceptible to snowstorms as it is today. Moving the core of the network to the general store also means that we're going to be moving the point-to-multipoint wireless network to this location as well, since it's a good central location that can feed wireless links to the rest of the town. For the point-to-multipoint network, we're going to go with the Rocket Prism AC and an attached 10 dBi omnidirectional antenna. For the inside of the general store, we're going to go with the U6 Plus access point. This is a great choice for areas where you're not going to have a ton of client devices, and it has the added benefit of these wood covers, which can help it blend in with the aesthetic of the store. You don't want visitors that are looking to be, kind of immersed in the history of the town, distracted by like this bright white futuristic access point hanging up on the wall. Outside in the little courtyard area between the general store and Brent's house, we're going to hang a U6 mesh access point. That should provide excellent coverage to both the outside area as well as Brent's house, and it can be painted to blend in with the wooden building. Since the UDM SE has an integrated PoE switch, it can power up both of these access points, as well as some cameras that can keep an eye on the museum and gift shop inside the general store. Brent said that they've had some issues with theft, so this should help put a stop to those problems. Let's now take a look at the rest of the locations that need wireless access. Moving clockwise from the general store, we first come back to the Gordon House. The existing Gordon House setup is actually pretty good, but I would make a couple of changes. First of all, I would get rid of that older UAP AC Pro and replace it with another U6 Plus. The U6 Plus upgrades the wireless coverage to Wi-Fi 6, and it can be installed with that wood cover to help it blend in. I'd keep the PoE injectors to power everything up, but I would clean up all of the wiring inside. On the exterior of the Gordon House, I'd also keep that NanoStation AC and the UAP ACM, since I do like to reuse equipment where it makes sense. Now, you could argue that the UAP ACM should be upgraded to the U6 mesh for Wi-Fi 6, but then you'd lose the ability to power up that exterior access point with the 24-volt passive PoE coming off the NanoStation AC's second Ethernet port. That being said, though, the location of the Gordon House's exterior equipment is on the wrong side of the building, right? So we're gonna have to relocate it to a spot that can actually see the omnidirectional antenna on top of the general store. The next location that needs coverage is a small outdoor area where Brent is building a recording studio for artists who are inspired by this beautiful location. It's a collection of 3 small outbuildings that can be covered by a single exterior access point. So for this location, I would go with another NanoStation AC to pick up the wireless connection from the general store, and then tack on a UAP ACM that's powered up by the secondary Ethernet port of the NanoStation. This way, you only need a single PoE injector for both pieces of equipment. Moving on, we have the American Hotel, which is still in the process of being built. Now, for the American Hotel, I would put a NanoBeam AC Gen 2 on the exterior to pick up that wireless connection from the omnidirectional antenna on top of the general store. I would power everything up with one of the new Switch Ultras and add on that 60-watt power adapter. For the NanoBeam, we'd also have to put in an 802.3 AT to 24-volt passive PoE adapter, but everything else can be powered directly from the Switch Ultra. For interior wireless, I would put a single U6 Plus with the wood cover. That's going to be more than enough access point to provide wireless coverage to the entire hotel, and again, it keeps that wood aesthetic to make it disappear into the background. Using the Switch Ultra also gives Brent the option of adding in some surveillance cameras to keep an eye on the hotel's common areas. The next area we need coverage is the old church. And they're going to be turning this into a gathering place of sorts. And as you can see, it has full-on metal siding. And as we all know, wireless does not go through metal. Because it has metal siding, it gets absolutely zero Wi-Fi inside. So to fix that, we can go with the NanoBeam AC Gen 2 on the exterior to pick up wireless from the general store, and then use that same dual PoE injector setup to power up a U6 Plus access point with a wood cover on the inside. In this case, we're just going to keep it super simple. Swinging around to the bunkhouse, we're going to rip out the mesh connected UAP ACLR and replace it with an identical setup to the Gordon House, where we have a NanoStation AC on the exterior picking up wireless from the general store, and it's also going to power up a UAP ACM access point. On the interior, we're going to have our dual PoE injector set up with another U6 Plus and wood cover to keep the aesthetics looking great. When designing this network, our goal was to keep each location set up as simple as possible, and we also tried to limit the variety of equipment used. This way, we can have some spares on hand to replace anything that breaks over time. One aspect that's not going to be simple, however, is the connection up to the Hoist House. Now, it's really hard to tell from the overhead pictures, but the Hoist House has zero visibility to any of the buildings in town. It's at a much higher elevation, and it's also blocked by tons and tons of dirt and rock that's been excavated from the mine. So how then can we get internet up to that location? The way I see it, there are a few possibilities. First, and really easiest, we can just leave the Hoist House and the mine shaft outside of the Dream Machine SE network entirely. The solar setup up on the hill has a nice line of sight to the Hoist House, and it's already working perfectly fine. The downside to leaving it as is that we lose a lot of capability, right? The internet wouldn't be redundant, and Brett also told us that he'd love to have some surveillance cameras down in the mine, mostly to keep an eye on the water pump at the 700 level. By keeping the Hoist House separate from the main LAN at the general store, we can't use Unify Protect for those cameras, or at least it would be much more difficult to do so. So we could also probably come up with some weird VLAN trickery to bring in the signal from the point-to-point access point on the solar setup, and then also piggyback on that connection in reverse to get the general store LAN back up to that solar setup and then over to the Hoist House. But that's a really complicated configuration, and this installation is about as remote as you can get. If anything goes wrong with that setup, it would be incredibly difficult to troubleshoot remotely. And since one of the main reasons Brent wants Wi-Fi all the way up and down that mine shaft is for communication and safety reasons when they're traveling up and down the elevator. So coming up with a simple and elegant solution is just going to be much better overall. I mean, just because you can do something doesn't mean that you should. So the best case scenario for getting the LAN network up to the Hoist House, in my opinion, is to use a separate point-to-point wireless link. And the only place in town where we might be able to feasibly get line of sight up to the Hoist House is going to be from the bunkhouse. And if we still can't get line of sight from the bunkhouse, we might actually be able to run a cable up to the outhouse that sits just about 30 feet up the hill from the bunkhouse. Even if we have to run the point-to-point access point up a pole like 10 feet or so, I think we would be able to make that work. We've been working with our contacts at Cerro Gordo to try to figure out if there is any possibility of line of sight from the Hoist House to the bunkhouse, and I think we're going to be able to do it. Now, assuming that it's going to be possible, we'll toss in one of the Unify Switch Ultras with the 60-watt power supply. We're going to add in an 802.3 AT to 24-volt passive PoE converter for a nanostation AC and the UAP ACM on the exterior of the bunkhouse. Then we'll add in another 802.3 AT to 24-volt PoE converter for a NanoBeam AC Gen 2 that's going to serve as the station-side wireless link up to the Hoist House. The Hoist House already has a NanoBeam AC Gen 2 that's currently receiving its signal from the solar point-to-multipoint setup, so that can simply be repurposed for this new link, though we're definitely going to have to move it to a spot that can actually see the bunkhouse. Now, believe it or not, this entire design that I've gone over so far is the easy part of this installation. Once we have a wireless link up to the Hoist House, we still have to deal with getting Wi-Fi down the mine shaft. And as we discussed with Brent, he would ideally like a wireless access point at every level of the mine. So now let's see what options Dave has come up with for that part of the project.
With a project like this, we have two major constraints: power and data. Going 900 feet with either is not as easy as it seems. With power, you need something like a very thick gauge cable to get it that distance if you want to have any type of load at all on that circuit. With data, your options are really fiber or some sort of repeated Ethernet solution. I went ahead and built two scenarios for us, a best case scenario and a second best. Let's take a look at what I'm calling the best case scenario. Now, there is one major assumption here, and that's that we got power the entire length of the mine. I'm not an electrician, I'm a networking guy, and this is why I'm calling this the best case scenario. But I do know if you're going this far with a power cable, there is a substantial voltage drop. And I know there are some tricks to get around that, which mainly include using a very thick gauge cable and maybe even stepping up the power to send it down. But let's talk about this a bit. The main mine shaft is labeled here as the Bell-Shaw shaft, and this goes straight down 900 feet, and up above it is the Hoist House. This is where they operate the man hoist that takes folks up and down through the mine. As it stands, there is some network equipment there in a NEMA enclosure, mainly a switch and an access point. And for this, we're going to go ahead and assume that's pretty much the same. The big question is, what are we doing down in the mine? So we effectively went ahead and containerized a solution. Basically, we boxed it up and we're going to make it the same for every single level for simplicity. We started off here with the USW Ultra switch. It's just a nice and versatile switch that can be powered with PoE or AC power, which is what we're going to use in this instance. We then went with the UK Ultra access point. Again, a nice, small, low-powered access point that's going to be fine for this scenario. Of course, it doesn't have Wi-Fi 6, but we don't need that here. And this is all going to be tidied up inside of a NEMA enclosure so that everything stays nice and dry. The only floor that's going to be a little bit different is the 700-foot level. Essentially, we're putting a camera here so they can monitor their water levels and their pump without having to send somebody the whole way down.
Leading all the way back here to where Cerro Gordo gets water. Look at that. It's incredible. You even got ducks down here. Didn't know we had life. Ow!
Like I said, this is actually pretty easy network-wise. The biggest issue is power. So let's take a look at the second best scenario here that maybe is the best of both worlds. The second option here is probably my favorite. It has a compromise both on the power end and on the data end. And I think with some cool technology that I'm going to show you here, it's going to be the best option. So it starts off a little bit different even in the Hoist House, way up here. So we're going to still use that UAP AC Mesh Pro, but for the switch, we're going to go with the USW Pro 8 PoE. This is a really nice switch. It has a great build quality, but also it has PoE++ outputs, and this is super important for the next step of this. As we go further down into the mine at the 100 and 200 foot level, we're actually going to use that PoE++ to power the USW Ultra switches we want to put here. And then in turn, they can power the UK Ultra that we're going to put on every single level. Again, that's just a very nice, low-powered access point that should fit our needs pretty well. And this is where we start to make a little bit of a compromise on the data connectivity side. And really this comes in at the 400 and 550 foot floor level. Essentially, we're skipping over them. They're just too far from the top to run any type of PoE power to them, and honestly, that area of the mine isn't really used very often, minus just the elevator shaft, of course, passing by whenever it goes down to the lower levels. And at the 700 foot level, there's actually a pump there, a water pump, ostensibly that allows us to get some sort of AC power off of there, which we're going to power the USW Ultra switch and the UK Ultra access point. Now this gives us a good solid place further down the mine with power that we can then use to build off for the other locations, such as the 900 foot, which we're planning of just putting a UK Ultra, a single Cat 6 drop down there and powering it over PoE. Now, if you're paying attention, you should be asking the question, well, how are you getting data to the 700 foot level? And that's a really good question. This red line here signifies a pretty cool technology. We actually found out about this through Tom Lawrence's YouTube channel, and it's called the Game Changer cable. Effectively, what this is Cat 6 cable that allows you to push and go further than the limits of standard Cat 6, and it has some cool technology of basically, thicker gauge cable, maybe some custom windings, stuff like that. And we're really going to use that to our advantage, not to send PoE power down, just basically getting internet connectivity to go from the 200 foot level down to the 700 foot level and allow us to give very solid connectivity throughout the mine. And that's honestly why I think this is a really good compromise. It doesn't require us to spend thousands of dollars of supplying power to every single floor along the way, but it gives us solid connectivity to all the key locations that we're looking for.
All right, so there you have it. I hope you guys enjoyed this video, and make sure you like and subscribe so that you don't miss part 2, where Dave and I come back to Cerro Gordo to actually implement the design that we created. All right, thank you guys so much for watching. We'll see you in the next video.